to introduce our presenters today by sharing my screen. So our first presenters today would be Mr. Chattupong Manakun. So Mr. Chattupong Manakun is currently a PhD student in water engineering and management program. His research interests include coastal stabilization, coastal erosion, headland bay beaches platform, littoral drift, and dynamic equilibrium. Coming today to WEM seminar, Mr. Chattupong would like to share with us the analysis of static and dynamic equilibrium bay beach in Southeast Asia. Coming up next, our second presenter is Ms. Dompon Pomomnut. So Ms. Pomomnut is a graduated master student from our program, Water Engineering and Management. Her research interests include mass fraction model, index models, leaching potential pesticides, and leaching potential vulnerability assessment. So Ms. Pomomnut will come to our WEM seminar series number 6 today with a presentation on assessing pesticides leaching potential in layered soil, a case study in Northeast region of Thailand. So with that, I would like to invite Ms. Chattupong to start sharing your screen and begin the today's WEM seminar series. Thank you.
Thank you, Dr. Locke. Good morning, everyone. My name is Chattupong Manakun. Today I will share you about my one of my study about analysis of static and dynamic equilibrium bay beach in Southeast Asia. So here are my contents. There are 3 parts: introduction, methodology results, and conclusion and recommendations. For the introduction, as we know that coastal zone has been subjected to an erosion problem for a long time, and there is a study indicates that half of the world's coastline is the headland bay beach. So this headland bay beach, there is a concept called equilibrium bay concept. This concept can be used for coastal stabilization. There are 2 types of this concept: static and dynamic equilibrium bay. The static is the case that there is no sediment supply into the bay, and the dynamic case is the case that there is sediment supply into the bay. We can see from here, if we assume that the shoreline is now the straight tangent shoreline, and when the wave approach to the shoreline, the erosion will occur, so that the erosion will continue until it reaches the equilibrium state, which is the state that there is no longshore sediment transport. For the dynamic case, for the same, if we assume the straight shoreline, and the difference is that now we have the river supply the sediment into the bay. And when the erosion occurs, it will stop when the incoming sediment is equal to the outgoing sediment. So the incoming sediment is from the river, and the outgoing sediment is the potential longshore sediment transport. For the static case, now we use the equation from Chu and Evans in 1989. It depends on the wave obliquity only, but it cannot be used for the dynamic case. So there is a new equation in 2014 from Tassadwok. It depends on 2 parameters, beta and SSR. The SSR is the sediment supply ratio. It is a ratio between the sediment supply into the bay and the potential longshore sediment transport. But this equation from Tassadwok was developed based on the experimental only. So this equation needs to be verified with the field data also. Here, as you can see, the equation from Chu and Tassadwok almost the same. The difference is that the parameter wave obliquity beta and SSR. And there is an alternative method to determine the erosion for the headland babies. So if we use this equation, we can determine the base shape of the dynamic or the static case. But if we only want to know the maximum erosion that can be occur, which is A here, we can use the empirical equation or the analytical solution here. But these equation they never verify with the field data. So in this study aims to verify this equation also, and we will show next in the results. For the objectives, so this study tried to verify the dynamic equilibrium Bay equation and also to understand the characteristics of the headland Bay beaches in Southeast Asia. Scope of work, locations of the headland Bay beach will obtain from the previous research work, and the beach planforms data are obtained from the satellite images. For the study area, so there are 5 countries: Myanmar, Thailand, Cambodia, Vietnam, and Malaysia. So as I mentioned before, Myanmar, Thailand, and Vietnam will be the location of the headland babies were obtained from the previous research work. Only Cambodia and Malaysia that I have to find a new location from this country. After I get the location of the headland babies, now I can collect the satellite image to find the shape of the bay and to analyze further. So here is the example of the analysis. This is the dynamic equilibrium bay in Cambodia. So after I collect the bay image in a time series in 32 years period, so I try to find that the shoreline will be changed or not after a long time or period to see whether the bay is in case of stable or unstable. As I mentioned before in the first slide, that the equilibrium bay, it means that the bay will stop, there will be no longer the erosion. So if the shoreline does not change, it means that the bay is in the stable and it reached the equilibrium state. After I know that a bay is a stable bay, I can develop my own model to determine and analyze the bay stability. In this study, I used the Julia language to develop a model because it's faster than Python. And I have to mention that before I have to develop the model because there is no model that can be used to predict the dynamic equilibrium bay planform. So I have to develop the model myself. In this model, it will automatically find the optimum SSR. So I don't have to trial and error again and again, because in another model, it is only the static case that can be used, and we have to try out the parameters see by ourselves. So here is the results from the analysis. This is the example of the multiple SSR. So we can see that the optimal SSR is the 0.064 here. It got EI over 99%. I analyzed every bay using this kind of the analysis, and it shows that it has the efficiency index greater than 90% for all of the bay. And I also fit the bay using the field data also in Thailand. For 5 bays, I use the data from field measurement and see that it can be equal to the SSR that using the model or not. And it seems that it has almost the same value with this EI also. Therefore, this equation from Tassador can be used and for the field application. For the characteristic of the headland babies from this study in Southeast Asia, so it can be seen that there are almost 60% of the dynamic equilibrium bay, and 20%, almost 30% of the dynamic equilibrium bay is unstable bay. So this means that the coastal stabilization for the dynamic case, it needs to be developed to stabilize the unstable bay, in this case of the dynamic equilibrium bay, which is almost 40 bays that can be used for stabilization from this method. And here are the characteristics of the bay. So it can be seen that the dynamic bay tends to be larger than the static bay here, and the wave obliquity for both cases are almost the same, as we can see from here. And from the maximum indentation, it shows some correlation that the larger the bay size, there will be a larger indentation. And the mean value for the sediment support ratio is 0.5. It means that there is a 15% of the potential longshore sediment transport. Here is I analyzed many parameters to try to find the relationship between parameters, and I only found that the parameter A and R naught has the linear relationship. I have to mention that I have tried many parameters, and only this relationship that show the some kind of relationship between parameters. And here is the A and R naught beta, and I try to fit it with the empirical equation from Chu and Evans and the analytical equation from Tassador, and it shows that this equation needs some improvement to be used in the field, as we can see that it does not fit the bay well for the static case. And for the dynamic case, we can see that the equation from Chu cannot be used as it does not fit the results well. And one thing that it can be seen that in very small SSR here, the result is very scattered. It means that the SSR is very sensitive for the small value, and it's less sensitive for the higher value. And this equation still needs some improvement. Also here is the same for the theta C. Theta C is to indicate the location of the A, the maximum indentation. And it shows that it still needs some improvement for both cases, for the static and the dynamic case. The last part, conclusion and recommendation. So a model of the dynamic equilibrium bay pain form prediction was developed in this study, and the model has been used to verify the equation from Tassador, and it shows that this equation can fit the bay well, and the number of the dynamic equilibrium bay is more than the static case, and almost 30% of the dynamic bay are unstable bay. And this means that we have to develop some cluster stabilization method for this dynamic equilibrium Bay also. And only the Bay parameters of R0 and A has the relationship, which is the linear relationship. And equation for the computing A over R0 and theta C should be improved using the field study that obtained from this study. For the recommendation, so the Task-Dual equation only verify with the 5 bays in the field from this study. So more data is better for the verification. And in the analysis, I have to define some kind of the control point and some kind of sensitivity is needed to study further to get the exact location of the dynamic the cost control point to get the better results for the model. And as I mentioned before, the application of the dynamic equilibrium concept need to be developed. Thank you. Dr. Locke, I think you did not.
Oh, sorry. Yes. So thank you, Mr. 𝐶𝐻𝐺𝐻 for giving this presentation to us, which is like quite interesting and I think quite close to the ground where we look at on the base and the evolution of the base. So with that, I would like to open the ground for comments and questions. So everyone, if have questions, please unmute yourself and ask question directly. Thank you. So Sanjeev, you have any question for 𝐶𝐻𝐺𝐻?
Yes. Good morning, sir.
Morning.
Sir, thank you, sir, for the opportunity. My name is Sanjeev Nyopane, and I'm currently a PhD student in Water Engineering and Management program in AIT. Thank you, Om, for this very comprehensive presentation. So, I don't have questions, but only one query. Like, since like we are studying that the climate change is increasing the sea level, and does this increase in the sea level affect the equilibrium of the bay?
Actually, it will not affect much because normally we consider about the wave obliquity. So as the climate change, I think that as the wind change direction, the wave obliquity change. This should be the more important parameter that we need to be considered for the bay, more than the sea level.
Okay, thank you.
Thank you.
Thank you, Sanjeev, for your question. Any more questions for 𝐶𝐻𝐺𝐻? So yes, so maybe I can take the platform and ask one question. So 𝐶𝐻𝐺𝐻, can you come to the slide where you develop the relationships between the parameters? Yes, yeah, this slide. So so this one is actually quite interesting because not only about the statistical basis, but can you explain the meaning of A and then also the R0, so that and then, you know, like not only we're interested in the statistical of the relationships, but also can you provide some interpretation why these two parameters have such a high correlation but not the others?
So for the A here, we can use it for determine the maximum indentation, which is it means it is the maximum erosion. We can use this to find the maximum erosion, and R naught here is the length, the radius here from the one headland to the another headland. So these two parameters can be used to define the size and the erosion of the bay. And why there is only these parameters that can be find the relationship, because as the wave obliquity there is almost the same, because when we consider the equilibrium bay, the wave obliquity should be the predominant wave direction. It should have the predominant direction. So almost every bay has the same wave direction, but it has the different size and have different erosion. So they do not show any relationship, only the geometric parameters that show some relationship.
Okay. Yes, I mean clearly from your diagram we can see that there are clear geometric relationships between these two parameters. And I have one more question. So from a theory and academic point of view, clearly your study is very significant and novel because there has not been a model developed for this particular purpose. But I mean, have you ever thought of taking one more step of how this particular study can assist in terms of disaster management or coastal management? And so have you thought of bringing this one closer to a real-world application?
For now, mostly we let me see. Before here we have the static case for the coastal stabilization. Normally we will construct the headland here, so the control point will be changed, so the bay shape will be smaller, right? But in my case, I can use this model to develop an alternative, a new method for coastal stabilization using the sediment supply into the bay. So as we know that beach nourishment is some kind of a way that we can use to stabilize the shoreline. So we can use that concept and combine it with this concept to stabilize the bay.
So in a way that this particular developed model can help the beach managers to how should I put it, like expect the development of the bay until when it reaches into the equilibrium state, and then what will be the expected shape of when it reaches to the equilibrium bay, considering also the sedimentation at the deposit, right?
Yes, and it can be used for some kind of, if we construction some reservoir and maybe some sediment supply into the bay will be smaller, so we can predict that what could be the bay shape that will be.
Okay. Yeah, that's indeed a very interesting information that the beach managers definitely would be put into good use. So any more questions from our audience? Okay, so if not, so thank you for Mr. Chayapon. And yeah, so may I invite our next presenter, Mr. Pon. So please start to share your screen and we can begin the second presentation for today's WEM seminar. So can you start to share your screen?
Yes, sir. Okay. Good morning, everyone. First of all, thank you for providing me with this opportunity to present the WEM seminar today. My name is Dongpon Pongkomnert from Thailand, a graduated master's degree student in water engineering and management field of study at AIT. Now I am going to present assessing pesticides leaching potential in layered soil, a case study in northeast regions of Thailand. Now we're coming to an outline of this presentation, which have background, statement problem, scope of the study, objectives of the study, study area and data collection, methodology, results and discussions, conclusions and recommendations. Overall, 8 main topics. First, starting with background of the study. There are several reasons that we should assess the pesticides leaching potential. Fertilizers and pesticides which are added into crops can produce more products. Population growth can lead to food insecurity because the more rising of population, the more lacking food too. There is an overuse of pesticides in Thailand. Look at the chart. Thailand is #1 out of top 10 import quantities of pesticides in Asia, with around 200,000 tons in 2018. Because most farmers decide to plant new varieties of crops that depends on agrochemicals to produce high yield. Moreover, the pesticide price also decreases. The excess use of pesticides in paddy fields can bring into damage of water resources and food as well, because it pollutes rivers, lakes, and groundwater, and poses risks for both the environment and human health. The proper assessment of pesticides leaching potentials in Thailand are needed because different pesticides in the region is important to avoid any potential negative impacts on the environment and human health. Speaking about the statement of problem, this is graphic from the data of National Health Security during the 10 months of year 2019 report. Patients admitted into hospitals across the country. Additionally, 3,067 patients who received treatment due to pesticide exposure, 407 deaths, and treatment costs more than 14.64 million baht. The total number of deaths caused by pesticide exposure during the 4 years from 2016 to 2019 is 2,193 cases, including a budget of over 20 million baht per year for medical expenses. Those numbers reflects the effects of the use of pesticides. Furthermore, pesticides can pollute rivers and lakes through runoff and groundwater through leaching. Overall objectives of this research is to assess the groundwater vulnerability to pesticides leaching through layered soil from paddy fields in northeastern Thailand. The specific objectives are as follows: to develop mass spectrum models for assessing relative leaching potentials of various agrochemicals in layered soils, to evaluate the accuracy of mass spectrum-based leaching models with respect to process-based HYDRAS 1D model results, to assess groundwater vulnerability to selected pesticides leaching in the northeastern Thailand. There are 6 scopes of the study: climatic data from Thai Meteorological Department from 2010 to 2019. Soil properties from Harmonized World Soil Database or HWSD. Three important properties of this study, which are soil, chemical, and recharge rate. Python programming for the assessment 𝐻𝐻1D model for comparing with the developed model. Now we're coming to the study area and data collection. Thailand is located in Southeast Asia on the Indochina Peninsula. A percentage of paddy field are 60% in northeast Thailand. Therefore, this study focuses on estimating a leaching potential of pesticide from paddy field in northeast Thailand. The table shows paddy crop calendar from Rice Department of Thailand on 2016. There are two growing seasons in northeast Thailand, which are in and off season. In season begin from June until the end of November, and off season begin from the mid-January until the end of May. Then we're coming to the data collections of this study. The data collection of this study, including weather data, are collected from TMD from 2010 until 2019 to estimate the recharge rate. The soil data from Harmonized World Soil Database and pesticide data from the literature. Methodology. The present study aims to develop a leaching potential model to assess the relative leaching potential of widely used top 5 pesticides for paddy fields in northeast Thailand, based on the revised attenuation factor or AFR, the mass fraction in layer soil. Therefore, the Python is used for scripting the assessment of AFR and MF models to compare with a point-based 𝐻𝐻1D solute transport to get the accuracies of the suitable models for the leaching potential vulnerability together with the Geographical Information System or GIS. Therefore, the point location basis simulated recharge rates from 𝐻𝐻1D was further interpolated using inverse distance weight or IDW method to construct spatially continuous recharge rates over the study area. Thus, the recharge database was integrated over the soil database by overlaying process in ArcGIS platform. Finally, assessing the groundwater vulnerability to selected pesticides in the northeast Thailand can be done by the geoprocessing functionality of ArcGIS in combination with Python using the ArcPy package. Moreover, the chemicals input can be selected which one that's supposed to assess when run the script. Results and discussions. First, the information of soil properties from HWSD. It shows the properties of soil that can be interpolated in the model. Second, the evaluations of recharge rate. It shows the recharge rates that calculated from 𝐻𝐻1D which needed in the developed model. Third, the simulations of the pesticide leach from physical-based model 𝐻𝐻1D. It shows the solute transport using 𝐻𝐻1D. Fourth, comparisons of the relative reaching order of chemicals between physical-based 𝐻𝐻1D and FR and MF models. It reveals the accuracies of the development model from comparing the development model with the HYDROS 1D, the physical model. Finally, the groundwater vulnerability map of widely used top 5 pesticides in paddy fields in Northeast Thailand shows that the most area with very high class is the study area that applied the paraquat, and lower class are chlorpyrifos, glyphosate, 2,4-D, and propanib, respectively. Now we coming to the conclusions and recommendations. The recharge rate results show that the recharge rate is different within the Northeast Thailand map. The simulations of point-based solute transport from HYDROS 1D at the 4 selected site locations shows that the 10 chemicals can be ranked. The lowest ranked is propanib for all 4 weather stations. The results reveal the accuracies of the FR and MF between HYDROS 1D at weather station 4. The accuracy between MF model and HYDROS 1D shows 100%. On the other hand, shows 0% with FR models. Furthermore, it is noted that the eastern part of the area was dominated by very high and high risk in the northeast of vulnerability maps, and those parts of the area should avoid utilizing the pesticides. Finally, the development of the vulnerability maps is useful for many aspects of water management. For example, prioritizing areas for monitoring, protection, further investigation, and the development of risk assessment, resource characterization, and education as well. Last, I apologize if there are any errors, and please feel free to leave the questions and comments. Thank you again for inviting me to this seminar.
So thank you, Tombon, for giving this presentation. And again, I'd like to say thank you for agreeing to step up to help Grace, our classmate, who's quite now uncertain about her travel. So thank you very much for stepping to help your classmate. So with that, I would like to open the floor for questions and comments. So I believe that there are quite a number of students in our water engineering and management program who's conducting research related to agriculture and agricultural water resources management. So if anyone have comments and suggestions, please unmute yourself and ask the questions. And before that, I would like to say thank you to Dr. Mohana Sundaram, who is the advisor of Ms. Onkot, who is here with us today. So thank you, Dr. Mohana, for joining us today.
Thank you, Dr. Log.
Yeah. So yes, so everyone, if you have questions, please unmute yourself and ask someone directly. So may I? So I invite Saurabh. I think you're also working in the field of agriculture. Maybe you have some not only questions but also some comments for this about presentation. Saurabh.
Yeah, thank you, Dr. Lok. Very nice presentation and very comprehensive work. I don't have any specific question, just a general question like what is your major limitations of your study? Like I think it's not a complete package. Yeah, your work is not a complete package. So can you just say us what is the limitations of your research?
The limitation?
Yeah.
Oh.
So how do you limit your scope of your work? Because your work may have some limitations. So as a person who have such research interest, so what are your limitations on your research, and how do you suggest them, like, okay, we have to see this limitation so that further research on this topic can be done?
So I use the important properties of these studies, which is the limited of the study, which are chemical source and recharge, to analyze for assessing the leaching potential of agrochemicals, because the formulas is providing the data, the three important properties of this study. So others, other data rather than three important properties, so I neglecting.
Okay. So other properties can be also included on the future research, so that this study can be made more comprehensive and more
Yes.
in line with the real field. Yeah. Thank you for your suggestion. Thank you, Dr.
Thank
Lock.
So thank you, Saurabh, for your questions. And actually, you have any from the audience? We are expecting some more questions. So anyone have questions for Ms. Tongpon? Okay, so if not, I take my permission to have some questions for you. So can you turn back to the slide of the results? Maybe you can start share screen again. Yes, it's a bit over. Yeah, okay. Yeah, so actually this slide is very interesting. And since you are presenting any, a lot of maps over here, I'm just curious that have you ever done any spatial correlations between the recharge rate and the pesticide concentrations? Or, I mean, not systematically, just a qualitative, when you observe, is there any like spatial correlations between these maps?
Not the maps. I just I only compare the accuracies of the FRMF models with the HYDROS 1D.
How about the spatial correlations? I understand about the accuracy. So you use these two models to compare with each other to justify the accuracy of your results. But have you ever done any kind of spatial correlations between, let's say, evaluation of recharge rate and the groundwater vulnerability?
No, sir.
Okay. Yeah, because I think that might be something interesting to look at. For example, you have more concentration, but at the same time, then you have more recharge rate. So that would that have any implications into the water the use? And the second question is like, can you come back to the methodology where you have a methodological framework? So over here, I understand that you are using two approaches. One is using remote sensing base. It's like interpolated RGS. And then you generate a ranking of the pesticides, and then at the same time you use HYDROS, right? So my question is, do you have any ground truth data, or you only compare two models together?
I only compared the model together with the HYDROS 1D.
Oh, okay. So you're comparing two models together, right? So apart from these two models, do you have any references like a real world, real measurements to compare, because from my understanding, two models are just like algorithms, so they might be prone to some internal biases. So have you collected any data or even recently published data to compare with the results from these two models?
The realistic data is only the climatic data from TMD from 2010 to 2019 in the model.
Yeah, but that is the input of the model, right? Not the data for calibration. So just my recommendation here is, like, if possible, maybe we can have some ground data. For example, when you think about the pesticides, right? Maybe there should be some measurements. Considering the situation, you might not be able to go on the field, but maybe some published data that for this particular region, this is the more prone to pesticides leaching, so that can improve the confidence of making the conclusions. That's just my recommendation. It would be better if you have some ground truth information. So so I think that's it from my side. Any more questions or comments to Ms. Tongpon for her presentation? Okay, so if not, I would like to say thank you again for your presentation. So before we wrap up today's WEM seminar series, I have a couple of announcements to make. So first of all, we have a poll for the best presenters of our first batch. So is Miss Yani available here? Yani, can you unmute yourself?
Yes.
Yes. So can you turn on your video as well? Okay. So we have agreed that we have a poll for the best presenters for our first 9 presenters. So Kunyani, may I invite you to make the announcement of the winner for our first batch? Yes, please, Kunyani.
Yes. I'm pleased to announce that the winner of the first round of the WEM seminar series 1 to series 5 is the Miss 𝐃𝐨𝐮𝐧𝐠.
Oh, so
yeah,
congratulations.
so she has been voting for the winner of the first round of the WEM seminar. Yeah.
Yes. Okay, can you share the script of the results as well?
Right now I use iPhone because
okay.
internet connecting at the office. Cannot share the screen.
Okay. Yes. So so congratulations to Amy for winning the first round. So I would like also to say thank you for those who have casted your vote for your WEM classmates. And Amy, I think she's not here, but maybe may I bother Kunjani to contact Miss Amy for the prize of
sure.
the best presenters. So thank you. Thank you very much. And also, I would like to say thank you to our alumni who has joined us today for today's WEM seminar series. The second announcement I would like to make is that today we have an Academy of Adaptation hosted by Professor Babel. So anyone, if you have time, please do join. So the link has been shared to everyone through email. Yeah, and then finally, as usual, I would like to invite our virtual photographer, Mr. Roel, to take a group photo for everyone. So I would like to invite everyone to turn on your video for a group photo. Thank you. So on your mark, Mr. Roel, so you just tell us on the panel.
Hello, good morning to everybody. Please smile in front of your camera. So for the first batch, okay, second. Okay, thank you very much for everybody.
Okay, thank you everyone, and please have a nice day and a nice week ahead. Thank you.